in third grade, students are expected to add and subtract time with time intervals of 15 minutes, 30 minutes, and 45 minutes. And one of the major struggles that students tend to have with adding and subtracting time is the base 60 approach, because students are used to solving problems out with the algorithms, and when they use the process, they use the base 10 approach. And so if we were to add and subtract time, we wouldn't end up with the correct time. For example, if we had 4:30 plus 7:45, we could add these numbers up, and in our ones place, we have 0 plus 5 equals 5. And in our tens place, we have 3 plus 4 equals 7. And then in our hundreds place, we would have 4 plus 7 equals 11. So, if you were doing regular addition and subtraction, this would be correct. However, when adding and subtracting time, there isn't a 75 minutes. It would have to regroup to the base 60. So we would have to regroup this, and we could do this by subtracting 60. And so in the ones place, you could do 5 minus 0 is 5. And in the tens place, it would be 7 minus 6 is 1. And then you would have to regroup, and that would make 11 a 12. So the actual time is supposed to be 12:15. So one way to help overcome this struggle with students is to use the SET model with a time tracker. So for our first problem, that's how we're going to solve it. And it says, Sally and John went to go watch a late night movie. If the movie starts at 9:30 p.m. and lasts for 2 hours and 45 minutes, what time will Sally and John leave the movie? So we know their start time is 9:30 p.m., so we'll put the 9 in the hours. And we know 30 minutes, so we'll put that in the 30 minutes column. And so we're trying to figure out how long or when they're going to get out of the movie. So it's going to take 2 hours and 45 minutes. So the first thing we need to do in this problem is get to the closest hour. So what we could use is a clock. And when using this clock, we could count by fives and skip counting. So we could move the minute hand and do 5, 10, 15, and then 20, 25, 30. So we know it takes 30 minutes to get to the closest hour, and then our hour would move up one. So we would go to 10 o'clock because we did added 30 minutes. 10 would go in the hours place, and then 2 zeros would go in the minutes. So now we took away 30 from our 45 minutes, so we could do 45 minus 30. And in the ones place, we have 5 minus 0, which we know is 5. And in the tens place, we have 4 minus 3, which we know is 1. So next, we would work with our hours, and we know the movie's 2 hours long. So we would add 60 minutes or 1 hour, because 60 minutes is equivalent to the 1 hour. So we would put this in our time tracker, plus 60 minutes or 1 hour. And if we added 1 hour to 10 o'clock, it would change to 11 o'clock. So we put 11 in the hours place. All right, and then we have 1 hour left. So we would add another 60 minutes or 1 hour in our time tracker. And then 11 would change to 12 because we added 1 hour. So we'd put the 12 in our hours column. And so now that we're out of hours, we would move back to our 15 minutes that we have left that we found out earlier in the problem. And we would put add 15 minutes in our time tracker. And so that would make the final time 12:15. However, we started out at 9:30 p.m. But at 12:15, it would change to a.m. So you could think of p.m. as lunchtime because noon is 12 p.m. and that's past morning. And then 12 a.m. or midnight we could think of at morning. So it would change to a.m. So for our next problem, we're going to use a linear model dealing with length of time. And we're going to be subtracting time this time. So let's read our question first. And it says, if Bill finished studying at 4:30 p.m. and he studied for 4 hours and 15 minutes, what time did Bill begin to study? So we know he finished studying at 4:30. So we're going to mark this. In our top column on our number line is our a.m. In our bottom column on our number line is p.m. So we're starting at p.m. So we would find 4 and then 30 p.m. So we're going to mark that for the finish time. And then I have a scratch paper over here. And we know he studied for 4 hours and 15 minutes. So I'm going to write that down on our scratch paper. 4 hours and then 15 minutes. And so just like our set model, we're going to go to the closest hour. So we would look, and 4 o'clock is our closest hour. So we're going to go to 4 o'clock, and we're subtracting 30 minutes because it goes 30, 15, and then 4 o'clock. So minus 30 minutes. So we would come over to our scratch paper, and we needed to subtract 30 minutes from our 4 hours and 15 minutes. So we can subtract 30. And then we need to regroup from the hours column. Except, unlike regular algorithms, we're going to regroup by 60 instead of by 10. So we need to make this 4 hours into 3 hours. And then instead of just making it 25 minutes, we need to make it plus 60. So you could do 60 plus 15. And in the ones column, you would get 5 because 0 plus 5. And in the tens column, you would get 6 plus 1 is 7. And so you would have 75 minutes. And so we have 75 minutes minus 30. And in our ones column, we have 5 minus 0 is 5. And then in our tens column, we have 7 minus 3 is going to give us 4. So we have 45 minutes left to go. And then we know we still have that 3 hours. So now we're going to go back to our number line. And we're going to start out with the hours this time. So we know we need to go subtract 3 hours. So we can go from 4 o'clock p.m. to 3. And that's minus 1 hour or 60 minutes. And then we can go from 3 o'clock to 2 o'clock, which is subtracting another hour. And we have one more to go because we know it's 3. And so 2 to 1 would be minus 1 more hour. And this would give us our 3 hours. So we used that. However, we still have 45 minutes left. So what we could do is skip count by 15s to subtract the 45 minutes. So 1 would go to 12:45, and that's subtracting 15 minutes. And then 12:45 to 12:30 would be subtracting another 15 minutes. And then 12:30 to 12:15 is subtracting that last 15 minutes. And that gives us our 45 minutes. So our final time would be 12:15 p.m.